Hi everybody, my name is Mutuan. Let's get started. But before we get started, we need to get that motivation, like how we always say, okay? Never skip a practice day. If you do the hey, you go fail hey. Easy say, easy play. Let's get started. So let's say here, a person pushes a lane more. Okay. So, oh man, I used to like this. Like when I was young, seeing people like cutting the grass, like. Man, I want to do that when I grow up. When I was young, so now we're gonna see now how that works as far as physics, the angle and the force, pushing force and pulling force. Okay, let's go to this question here. Without further ado, I'm gonna push my calculator aside. Let's get started. So let's say here, look, this man here, okay, get my pen ready. Okay, so let's say a person pushes a lawnmower. Okay, but that lawnmower has what? A person pushes a lawnmower of mass. Oh, so this is a mass of lawnmower equal to 1.5, but has a constant speed in a straight line. Oh, so when they push this stuff of got constant speed, but anything with a constant speed always acceleration equals to zero. So you might ask me like, how you know acceleration equals to zero? Just in case it's not part of the question, but just to let you understand, because our intention is to get you to understand. Look, acceleration always equal to change in velocity over change in time or over time. Let's just say over time. So we say always change in velocity means velocity final minus velocity initial over time. Okay. So when you say velocity is constant, meaning when you start velocity, you start doing whatever you do after maybe 2 minutes in the same velocity. It means the velocity is TD. It did not change. So for that case, let's say velocity final equal to 20. Let's say 2 meters per second. Minus velocity initial so equal to 2 meters per second. Why am I writing the same? Because you say it's constant. So final velocity equal to the initial velocity, and then we over. Let's say 2 minutes, but you have to change your time to second. So 2 minutes equal to 121 seconds. So look, 2 minus 2 equal to 0. 0 divided by anything by 120 equal to 0. Oh, that's why when you say the velocity is constant, meaning the same velocity, that's why we say acceleration equal to 0, because this is going to give us acceleration equal to 0. Oh, now I understand. Oh, yeah, that's how you should understand. Okay, so now we say not only that, even when an object is stationary, because if something is stationary means it's not moving, means the velocity equal to 0, means the velocity of all this stuff, if it was at stationary, equal to 0. So 0 over time, let's say 120 or any time equal to 0. So you have to know that when you have a constant velocity, acceleration equal to 0. Acceleration equal to 0. Now we go. So now we say, back to the question here. Back to the question. Okay. Now they say here, acceleration equal to 0, just like I say. Now they say a hander. Now they say these guys apply the force over, okay, with it over flat surface with the force. Oh, so when he was pushing a force like he pushing, oh, so there's a force here which equal 20 Newton, 90 Newton, sorry, 90 Newton, 90 Newton, and then, oh my God, and then what happened then? So they say here is directed along the handler. Oh, so this force is like it's been directed along the handler. You push. Now, what is the question now? Let's go. But, okay, but it make angle what? 40 to the horizontal. Oh, so if you have to make horizontal, means it make angle what? Angle 40 here. The angle is 40, but this force equal to 90 Newton. Let's write it underneath. Okay, now let's go for the first question. They say, draw free body diagram of the lawnmower. Okay, easy. What you do for you to draw free body diagram, you need to know the force diagram. Look, what is the force exert on this in this lawnmower? Okay, let's go. This is a lawnmower, right? So we know it must be force of gravity, which acts toward the center of the earth. Also, at the same time, since there's a force of gravity, it must be a force which is opposite. Which force is that? Normal force. From the ground here in this surface toward an object, you say force of normal. But also at the same time, we have what? This force applied, or just a force which this means applied. Let's see other force. But remember this object moving to the right, moving this way to the right. Okay, where does it move? It moves this way. But we don't have any force here, no? But we know for fix we must have a friction force here, which is opposite. See? You see what I'm saying? Friction force. So this is called friction force, FF. FF friction force. See? Can we do this? F capital and F smaller, friction force. So the force which is making move to this direction is this force which is pushing. So this is the force diagram. So now they don't want force diagram, they want what? Free body diagram. Okay, so free body diagram, what you do, you come in and draw like, look, you do this, look. Draw your line more, and then write all the force acting. The first force is what is? This force here, which is 90 degree force applied. So I can just say this force applied. And another force, force of gravity. Force of gravity. Another force, normal force. Another force, friction force. That's all. So these are only force that you have. But sometimes, if you don't want to write like that, you could have just say, okay, if let's say I don't want to write this force here, I can write here instead. Say force applied. And then I can remove this. See, 8 of the 2, you're going to get the marks. And then you must come and say, okay, what is Fn? You must define it. Say, okay, Fn, whereby Fn equal to normal force. And then FF, friction force. For you to have all the marks. Friction force. Fg, force of gravity. Okay, Fg, and then we go for Fa, applied force. Pushing force of applied force. You can say PFA or FP, whatever you think is convenient force, applied force. Now we're done with the first part. Now let's go for the second question. What is the question for the second question? See what I'm saying? So just like I would say, force diagram is gonna be like that. FA. Excuse my apology. Excuse me, sorry. I'm so sorry, my apology. Okay. Can you believe now it's 6 o'clock? I didn't sleep last night. Okay. So you draw all this force diagram. Force of gravity. I'm just concerned maybe you didn't see this, friction force, and this is the force applied. And then when you finish, you must say, oh, this is normal force, man. It's not FA, FN, normal force. That's all. And then you say Fn meaning force of normal, Fg, force of gravity or gravitational force, F is a force applied or pushing force, and this FF is a friction force. So now we're done with this, okay? So after we're done that question, now we go for the next one. We'll do the one. Okay, force of gravity. So now what do they want these people? For the second one, they say what the correct, okay, hold on. What they correct to say that the moving lane mower is at equilibrium. You know, equilibrium is something which is balanced. So in other way, here when they say, oh, the one they say y is a correct statement. Oh, y is the correct statement. Why the correct statement that the lane mower is at, okay. So when you say something at equilibrium, meaning this lane mower will move with a constant speed, because when you move with a constant speed means it does not accelerate. Oh, so meaning, you can say here meaning it move. Okay, I can just say, okay, let me just pull this one here. This is a definition, then I don't have to waste a lot of time, and then you can just check this. I hope you can see. Let me change the color here. Invisible or black. And now let's put black, and then let's change the format here for just a second so you can see what that means. Just a definition. Okay. So now we say, saying thank you. So say, okay. Okay. So now when you say something at equilibrium, for now we know because it was moving with a constant speed, it's in a straight line. For that case, since it's the constant speed, we know acceleration is going to be equal to 0, which I showed already. Okay. Or sometime you can say net resultant force equal to 0, or you can say it move with a constant velocity. It's the same thing. Should I break it down slowly? You understand? So you say at equilibrium, what does that mean? We know it's going to be moving at a constant speed or constant velocity. But when anything is at a constant velocity, mean acceleration equal to 0. That's all. So that's what I say here in definitions. Now we got it. Okay. Just a second, just say it doesn't want to go away. And I need to take it away because okay. Just a second. I'm gonna take it away now. Okay, cool. I got it. Okay. So we're done with the second one. Now we want to go for the third one. Third one, they say, okay, look, calculate the magnitude of the friction force acting between the lawnmower and the grass. Okay, look. So if you want to get friction force here, let me show you this. You want to get the friction force. Okay, look. If you push this stuff here, you push, right? So meaning we have a force like that. Do you agree with me? See? So if I want to get the horizontal force, like let's say here, remember this angle here from math grade 9. This angle equal to this angle, corresponding angle. See, for math grade 9. So I'm gonna say, look, this is 40 given, meaning even this look line, so even this can be 40 also, corresponding angle. So for that case now, I'm gonna say, look, if this angle is 40 and we know this is 90, they give us 90 Newton. Meaning, if this 90, let's connect now. Let's make a triangle. Da, 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 da. But in math, we know, in mathematics, we know, look, if somebody give a triangle like this, for example, I'll come here, right? And they say, let's say this is 30. Now let's say this is 10 Newton. Oh my God, can you see that 30? Okay, let's use another color. This is 30, let's say. Now let's say find the horizontal. Horizontal is cos. Horizontal is cos. Remember this. So I'm gonna say cos. What is my angle? 30, and always multiplied by this hypotenuse, which is 10. So this is gonna give us what the horizontal. Simple like that. What is vertical? Vertical is sine. So here we want to say sine. What is my angle? 30, and you must multiply by this hypotenuse 10. And this is gonna give us what? Opposite. Oh, so adjacent is cos. Oh yes, adjacent is cos. But why do they look? Because I know this force, so let's connect it, make a triangle here. If you make a triangle, mean that triangle is gonna look like this. Look. I want to go to 40, and then 40 degree. My God, sorry. Back for this triangle. Okay. Now we have hypotenuse equal to 90 Newton because they kind of turn this triangle. So I want to get the adjacent here. So what is adjacent? Adjacent equal to cos. So I'm going to say it's going to be cos. What is my angle? 40 times by hypotenuse equal to 90 Newton. Oh, so for that case, I want to get this force which is moving this way by resolving this triangle. So this is opposite, this is adjacent. Adjacent is cos. So I can simply say cos of what? 40, and then multiply by hypotenuse equal to 90. So this force is going to be moved that way after we resolve. So for that case, now I'm going to say, see? So let's say find the magnitude of the friction force is easy. So first you need to determine where this object is moving. Is the object moving this way or this way? Or this object moving this way to accelerate this way? Meaning, for that case, the force which makes this object accelerate is this force here. Because that's the one which is to there. That's why I have to resolve the vector. I'm going to say from Newton's second law of motion, Newton's second law is say F net or resultant force equal to mass times acceleration. But remember, this object move with a constant speed. Remember, you push the dimension, they say it's going to move with a constant speed. For the first part, they say it's going to move with a constant speed. They actually say, see, you move with a constant speed. So for that case, acceleration is going to be equal to 0. So mass times 0 equal to 0, because mass we have equal to 15, but at times 0, acceleration equal to 0. So all this stuff in the next step is going to be okay. But what is F net? F net, look the force which is making this object move to the right, which is what is 90 cos of 40. So I'm going to say 90 minus, because this object is moving to the right, to this direction. So this is 90 cos 30 minus, which force opposing? Only one force, FF. But this is going to be equal to 0. Why equal to 0? Because the acceleration equal to 0. So what we're going to take this over, friction force. So 90 is 90, it's not nice. 90 cos theta cos 40 equal to FF. Because this is equal to 0. So now, put this in a calculator. If you plug in a calculator, FF equal to 68, 94, 39, and 4, let's 4 in approximation. What Newton? Oh, so now we have a friction force which equals 68.9944. Oh, so now we have a friction force. Very good. I got it. Now we have what? We have a friction force. Okay, so now for here friction force, so for the 2.13 friction force equal to 68.94 Newton. Now let's go for the next one. Now they say the landmark now is brought to rest. The landmark is now brought to stop. So do we stop? But now let's read again. More. They say calculate the magnitude of the constant velocity, constant force. Oh, we want to get that constant force because remember we were pushing it in a constant. So we're gonna get that constant force. Okay. What we want to get? We want to get that constant force. How are we gonna get that constant force? But they have said here, okay, through the handle of accelerated landmark from rest it to. Oh, so what they say is like you start, you want to start now, rest it to 2 meters. Say, let's get start. Oh, so we start from rest means it will start moving, and then start to move the constant velocity, which is equal to 2 from 0 to 2 in a 3 second. Okay, that's easy. So what I'm gonna do now, they give me some data here. Okay, they give me what? It start from 0 means velocity initial equal to 0, but velocity final. Velocity final. What is the velocity final? Or velocity constant? Oh my god, I'm writing on top. Let me write down a little. So say velocity initial equal to 0, but then this velocity increased to 2 meters per second. Okay. But then what happened? They give us time here. What is the time? Time equal to 3 seconds. So with this will help me to get acceleration. And why do I need acceleration? Because I know in the Newton's second law of motion is going to help me. Okay, how we want to say from equation of motion, we have this equation of motion, say velocity equal to initial velocity final equal to initial. Man, what am I doing here? Excuse me, I made a mistake, sorry. Sorry, my apologies. Everything's fine by the way how I wrote it. Look, they say this is the acceleration from initial equal to 0, u equal to 0, I say h. That was a mistake. I'm supposed to write u. And then it move to velocity final equal to 2 meters per second. Means it start to go what? It start to be constant, like it does not change. So now they say here, time. What time is taking? Time is to go 3 seconds, if I'm not mistaken. Yeah. Time is 3 seconds. 3 seconds. Now what do they want? They say now magnitude of the constant force. Oh, so they want the constant force. If this stuff will start from rest and it went all the way to 2. So this is a new force now, the one, not that force we had. I'm gonna say here, look, if this stuff moving, okay, like how we say, look, so I'm gonna resolve this first. So this is 40. If this 40, look from there, like we say, if this 40, this can be equal to 40. So if this is 40, means even this can be equal to 40 from the corresponding rule. So this can be equal to 40. But remember, this is not 90 anymore. This is a new force. Let's go F dash. So this one here in the horizontal, remember horizontal is cos. Like, look, our triangles like this. So we got F dash, we don't know. Okay, and our angle equal to 40. So now how are we going to get the horizontal? Because my intention is to get the horizontal. This. So I'm going to say equal to horizontal is cos. So I'll say cos. What is the angle? Angle equal to 40. And then you always multiply by this hypotenuse, which you don't know. We call it F dash. For now, we don't know because that's what we're looking for now. So now I'm going to say then F dash what? Cos of theta. So this angle here, I mean this force equal to F dash for now. Cos of what? Cos of 40. So we're going to say now, since it's moving to the right, then we're going to say F dash cos of what? Cos of 40 minus which force opposite? Friction force, which we know because the friction force of the surface can be the same. Friction force equal to mass times acceleration. So the question is, what you're looking for first? I'm looking for this. Do I know cos of 30? Yes and no. Do we know friction? Oh yes, we have friction here. Mass do you have? Mass I do have of the length more. Acceleration, I don't have acceleration. Let's find acceleration. So first, and then we're going to come and substitute the acceleration. Velocity final minus velocity initial over t. See? And then we can say, what is our velocity final? Velocity final we say 2 minus 0 because they say here, you move from racing to 2 and over. How long did it take? It took 3 seconds if I'm not mistaken. 3 seconds. So now this is going to give us 2 over 3. Oh, so acceleration equal 2 over 3. So this acceleration can simply come here. Is 2 over 3. So now we can substitute everything and we can get a constant force. Okay, we can get a constant force. So now then we say, okay, then we say, look, friction force we know equal to 68.94, but this is going to come here. So we're going to say F1 cos of 40 minus, let's say equal, because this is going to come here. So mass, what is a mass? A mass equal to 15 kilogram. Acceleration equal to 2 over 3. We just got its acceleration now. Plus FF, but what is the friction force? 68.94. So what we want here, we want to get the value of F dash. We can get it because what I'm going to do, I'm going to divide by cos of 40, divide by cos of 40. So this and this cancel. So for that case, now we can simply plug in the calculator. But look, by 3, 1, how many 3 and 15 there? 5. 5 times 2 equal to? 5 times 2 equal 10. 10 plus 68, 94 equal to 78.94 divided by cos of 30. Oh, so this is going to be, it's going to be what? Excuse me. Okay, so I can just simply finish up here because we don't need diagram anymore. We just wrap it up now from the basic equation. So we're going to say F dash equal to, okay, now we say by 31 by 32, 2. 2 times 5 equal to 10 plus 68.94 over cos of 40. So F dash, so what we're going to do is going to be equal to 103.05 Newton. So that's going to be the force when objects start from rest and they start to move with a constant velocity. Now let's go to the next question. But before we go to the next question, I mean this one here, look, some of you might be new here, right? So make sure, please, you come right here and you subscribe if you're not yet, okay? Now let's go to the next one, okay? The next one is easy. So I'm going to make a space here quick. And let's do the second question here. I mean 2.2. Question 2.2. Let's do it. Okay, question 2.2. So the question 2.2, they say here, a planet Y. Okay, let's assume this planet Y here. Okay, planet what? Planet Y. So what happened to this planet? Okay, let's draw down a little bit. Planet Y. And then, so this planet Y, they say has a radius of 6.8. Oh, so it has, oh man, this planet was right. Okay, so it has a radius from here, center to there. So radius is radius of planet, let's say R of P. R, what is the radius of the planet? Equal to 6 times 10 power 5. 6 10 power 5 what meter? Okay, so there is a weight on the surface. Oh, so there's another mass of 10 kilogram. Okay, a 10 kilogram mass weight 10 newton on the surface. Okay, so I'm going to say we have something on the surface here. But this something has what? Has it? Mass of 10 kilogram, but it weight what? You know why they say to weight 20? Because the gravitation there, I think it's going to be 10. Because look, we're going to say, so now we're going to say the radius of an object on the surface, because they say there's an object on the surface. So now what do they want us to find? Okay, can go there? Mass of planet what? Y. Mass of the planet Y. Okay. So now we have from the Newton's law of gravitational. Newton's law of gravitational. Newton's law of gravitational. How does he say? He say very. Say always F equal to G gravitational constant. They say mass of two things. May say for now is mass of the. You multiply those two mass of the. What was on the surface of the Earth? Planet Y. So let's say mass of the planet Y. And mass of the object, let's say M. Over. So what you do, you over the square of the radius. This is a formula you memorize. Or you can say M1 times M2 over R square. You can simply say M1 times M2 times R square. M1 times M2 over R square. R square. So what we're going to do now, we can simply plug it in, excuse me. So now, before we plug it in, they say something there. They say an object is on a surface. So means the force which is going to be exerted is the force of the object on this planet. So what the force is mass times gravity. So here we're going to say gravitational constant, mass of the planet, let's go M1 and then times M2, which is the mass of because there's a planet and object on the Earth. And then we over square R square, means R to the center of the Earth. But look, one mass in, one mass cancel. So for that case now, we have most of the information here. Okay, R we have radius. Gravitational constant we have G 9.8. So they want us to find. They want us to find this. We can get it easy because everything else we have. So I'm going to say, let me say over 1, say G times R square equal to G R square. And G times M, GM. So I'm going to say GM equal to G R square. Oh my God, no. Equal to small g R square. Because look, you cross. G R square equal to GM. Because this M and small m cancel, means those another mass. So now we want to get what? We want to get the value for what they say? The value of the radius. So we want to get this radius. So divided by G, divided by G. Okay? And then we say this G and G cancel. So we can just finish up. And then we say we left with R squared equal to gravitational constant times mass given over G. So we're gonna square root and we're gonna square root. So this and this cancel. So R equal to gravitational constant times mass, which we have called them, divided by G square root. So what we're gonna do now, we can just plug it in easy. What is G? Gravitational constant. Gravitational constant equal to 6.6. This one is constant, so you don't even have to calculate it, memorize. 6 times 6.7, 6.67, 6.67 times 10 or negative 11, and then multiply by mass. What is the mass? 10 kilogram over G. G is 9.8. And what you have to do, remember, you have to square root. So plug in the square root. Okay? Excuse me, sorry. No, man, what am I doing? I'm wrong, Femi. I'm not looking for that. I look for something which they didn't ask me, and I'm wrong because we're looking for the mass. What we're looking for here, the mass of the planet. So what I did here, it was wrong. See what I'm saying? It was total wrong. So I'm gonna say now, let's make my subjects again. I made a mistake. My apology on the second one. So we say, look, we say what? Mass times gravity equal to G mass times another mass. Let's call this M1, M2. So there's going to be only one M. So we want to get the mass. Okay, we want to get to the mass of another one. Okay, so now let's call this. Let's call one mass is the mass of the planet. Let's call MP. Okay, mass of the planet and mass of the object on top. Let's say mass of the object. Let's say mass of B. Let's say mass 2. So here we come. Okay, we say. Now here we say. Yeah, we have a force. My apologies, my force. Let me say it slowly, man. Oh my God. So we say force equal to G M1 M2 over R squared. But of course we have family. We have the force. You know what we're looking for now? We're looking for another mass, which is the mass of the planet. It's easier to get mass of planet. Let's call this mass of the planet MP. So first we have on a planet Earth, which is 20 Newton. Because they say here is 20 Newton. Equal to G. G equal to, we know our G. Our G equals 6.67. 10 power negative 11 times mass 1. Mass 1 equal to 10 because they say here the mass is 10, mass of the weight, 10. The mass 2, that's what we're looking for. See, let's call mass of the planet. Let's say this is the mass of the planet. So over. Square of the radius, we know the square of the radius, which is what is 6.6 times 10 power 5. So what we can do now, we can simply make the subjects what? This mass of the planet. So we can say this is over 1, and then we can cross multiplication, and then we can make the subjects. Because what we're going to do, we're going to multiply this 2, this and that, which is going to give us 20. Let's do this. Excuse me, sorry. Okay, let's start with 1 multiplied by this because I can start with this. So 1 multiplied by this is going to be the same thing, which is 6.67 times 10 power negative 11 multiplied by 10 multiplied by mass of the planet we're looking for, equal to 20 times 6 times 10 power, but remember there's a square here, right? So do not forget your square, please. 10 power 5, and all this stuff you must what? Make sure you square. So we want to get the mass of the planet. So what we're going to do, we're going to divide both sides by 6.67 times 10 power negative 11 times 10 on the left. Divide this, and here also you divide by the same thing, 6.67 times 10 power negative 11. Then what we do, square times 10. So now, this and this cancel. So now we're left with mass of the planet. Mass of the planet equal to, plug in the calculator. If you plug in the calculator, everything's take this all divide, and this is going to give us 1.08 times 10, 22 kilogram. See, so that's how you do this question. So if you first time here, man, subscribe right here. If you're new, make sure you come subscribe, show me support, share this video. Do not keep to yourself, share to other people so they can see the easy life. Okay, peace and love. I'll see you very soon, and I'm out here. Thanks a lot. I appreciate it. Bye.